Okay, so let's see if we can graph a parabola. Let's start with an equation. And one way that we know that this is a parabola is because it's an x squared, and then the y is not squared. So if one of the variables is squared, it's generally a parabola. There are different ways to graph these things. I'm not going to say that this is the best way to do it, but this will work most cases. So a good thing to do for parabolas is to find out where your vertex is. So we have a formula for that that works really well if the parabola is in the form of an x squared minus and then an x and minus an 8, or it could be anything in terms of pluses or minuses, but you just need it in this form. So the b would be the number in front of the x, so make sure that you are careful with your negatives there. And then the a is the number in front of your x squared term, and even though we can't see it there, there's a 1. And so we're going to get the following. We're going to get 2 over 2, which would equal 1. So the vertex, which is either the lowest or the highest point, occurs at an x value of 1. Well, then how do you find out the y value? Well, you could just plug it in, so let's do that. So 1 squared minus 2 times 1 minus 8 would be, let's see, 1 squared minus 2 minus 8, that's a negative 10, so that should be a negative 9. I'm going to give myself enough space there, but that will work. And at this point, you can just go back to old reliable, so step 2, and that would be just make a table. So the reason I picked my vertex first is because I know that my vertex occurs around 1, negative 9. So what happens then at 0 or at 2? Well, the good thing about a parabola is that it has symmetry around the vertex. So whatever happens at 0, and at 0, if I plug it in, so 0 squared minus 2 times 0 minus 8, so it's a bunch of zeros, minus 8 is just a negative 8. So I would also get that here. That's really not enough yet, so then I could go look for more points. So what happens, for example, at a negative 1? That would then also happen right here at 3. Probably easier to work with the positive value, so I'm going to actually fill in the 3. So 3 squared minus 2 times 3 minus 8, so that's 9 minus 8, which is 1, minus 6, and 6 minus 1 is a negative 5. So that would also occur over here. Another thing that you would probably want to know would be, where are the zeros for my parabola? Well, the zeros would be x-intercepts or roots. Let's see, are there any other names? Sometimes people call them solutions as well. So those are 4 names for the same thing, and it just means that I want to know at what x is my y value 0. Well, this one looks like a nice little factoring problem. If I make it x minus 4 times x plus 2, then I can solve this pretty quickly with x is 4 here, and x is a negative 2 there. So you can see that those would be my next 2 spots in my x and my y table. And at this point, I'm pretty much ready to go ahead and graph it. Now, this is going to be more of a sketch than a graph. So here's a y-axis. Then I need the x-axis, so it comes up from the negative, so let's do it this way. Put some tick marks on there. So let's see, let's put it at 1, at 2, and at 3, and then 1 at 4, because that's in 0, and then a negative 1 and a negative 2, and that should be good enough. So I get a 0 here, and a 0 over here at 4. At 0, I was at a negative 9, so let's call that a negative 5, and that would be a negative 10-ish. Let's put those down. So there's a negative 9, and then, whoa, 0 should be at a negative 8. I've got to erase that. So 5, 6, 7, 8, 9. So there's a 0. At 1, I have my vertex. At 2, I have a 0. And then at 3, should have a -5, which I also happen to have on this side, and then you do the best that you can with the parabola. And then that would be one way to graph a parabola. Maybe not the best way, but certainly uses several of the techniques that you ought to be familiar with, and in the end you get a result that works. Thank you.